Alright, so I know it's been a while since I posted a video. Been waiting for some parts to come in for this 460 build. Turns out that I had to order some custom made valve springs. One of the few parts that you can't just buy offline for these types of build. A lot of it has to do with your valve train, and you run into these problems when you start running higher lifts. If you get into the lifts in the area of, say, above 400, you're going to end up with valve train geometry issues, clearance issues between your guide and your retainer, and stuff like that. The issues I was having after basically getting my I ended up getting some longer valves. The longer valves let me keep my or let me run my lift without coming into retainer to guide clearance issues. And what I mean by retainer to guide clearance issues is here on the head. These are the valves that I'm actually running. So say this is my intake valve. The issues I'm talking about is, you know, when you run your lift, really high lift, this retainer actually comes down and bumps your guide. So you need to keep probably minimum of 40 thousandths between your retainer and your guide. So in order to do that and run the lifts, you're going to need longer valves. And when you put longer valves in, your valves and your valve springs have a certain install height. So when you swap out, say, you know, your stock springs for some of these NR Racing dual springs, 65 pounds, they want an install height at 1.2 inches. So now if you run a longer valve, like I have, my install height is 1.35, which is 150 thousandths longer, or a taller install height than those springs. And if I use those NR Racing springs, they wouldn't have the correct seat pressure, and they wouldn't be able to control the valve train. And to get your RPMs high enough, what you need is to be able to control your valve springs. Okay, so this is the valve spring from NR Racing, and this is the valve spring from Manley. So as you can see, this spring has 1, 2, 3, 4, and then the two ends, so call it 6 coils. This one has 1, 2, 3, 4, and then the two ends, call it 6 coils. This one uses a dual spring. This is a single spring. This spring wants an install height of 1.2 inches. At 1.2 inches, it gives you 65 pounds of pressure when the valve is on the seat. The open pressure, or pressure on the nose, is 140 pounds. These are made for stock size valve, and basically for running up to 375 lift. These valve springs are a custom valve spring, and these are made for running bigger valves like I'm running, you know, when you get into the bigger valve, the 30s, the 40s, 42s, and bigger lifts. So I'll give you what the NR spring, and this spring is, sorry, my camera just died. But so the NR racing spring has a 1/200 install height. This spring that I custom had made, this is silicon carbon, silicon chrome. It has basically been heat treated and has been shot peened and can withstand RPM reversion up to 11,000 RPM. So I'll give you some specs on the spring itself. I'll grab my caliper. So the spring itself, so let's go with the outside spring of the NR Racing spring. Make sure this is zeroed. We'll go to inches. So the outside diameter of this spring is roughly an inch. Okay. The inside diameter of this spring is roughly 741 thousandths. Now the guides, the retainers, I'm sorry, receive a spring, or the groove on them is cut to 745. So the inside of the spring kind of has to line up with the retainer. You see? So the retainer has to hold the spring in place. So these are the new springs I have. Now they're a single spring, so I don't have to worry about the dual springs. Now this spring is a lot wider. It's a little bit, it's probably about, it's almost 70 thousandths wider. The other one was like 995. This is 164. It's like 70 thousandths wider. Now, the NR spring fits on the retainer. It rides just inside the retainer, like this, almost flush. Everything's flush. Now the new spring is a little bit fatter than the retainer. Now these springs can run a higher lift and will not coil bind. Also, these springs, when the valve is seated, have 87 pounds of seat pressure. When the valve is open on the nose of the cam, it has like 190. It has a rate per inch of 245. Now every engine, depending upon valves, valve size, valve weight, and RPM, and stem thickness, there's a bunch of variables, and lift, but there is an ideal spring. Basically, if you call Manley or Ferrera or, you know, even Summit Racing, you know, a lot of these companies are affiliated with each other. You can order yourself custom-made valve springs. Now these valve springs cost me $40 each. These are the highest quality valve springs you can buy, custom made for my exact application. So I basically gave them my valve weight, my valve stem width, my retainer width, inside diameter, the outside diameter working within, and my valve lift, and my retainer to guide minimum clearances, and they made me these springs. I had these springs made specifically to control my valves at higher RPMs, allowing me to make more power. Basically, the limiting factor to an engine is, you know, if everything is built right, valve float becomes your limiting factor. When those valves start to float at 10,000 RPMs, the valves open and close in probably like 60 to 70 times per second. So you think about how quickly that is. So if that valve even bounces, the time it takes it to bounce is all it takes for it to lose that compression, to lose that seal, and your engine stops revving. So being able to control your valves is everything. So I have here a few valves. This is a stock valve, and you can see the height. Here is basically the same valve, but a Bullfrog Racing valve, and you could see the length difference over a stock valve. Now if you took a stock spring and put it on this Bullfrog valve, you're going to have incorrect install height, and that spring is not going to function. It might function to a point, but you're going to start floating the valve, especially if this valve is heavier and longer. Your spring geometry is going to be all out of whack. So I have here a stock valve spring. Here is an NR Racing valve spring. If you can see, I'm going to try to hold these flush. And then we have, say, a Bullfrog Racing. Let me get behind the camera. I might be able to do this better. But you can see the NR Racing valve is slightly taller than that, and then the Bullfrog Racing is even taller than that. They're all flush at the bottom here. So you can see the height difference. So as the valve gets longer, that 65-pound spring that you're using from NR Racing or whoever, it doesn't know any better. You know, it doesn't know the valve's longer. It doesn't know the install height's wrong. All it knows is that it's trying to bounce. And if you put the valve, a longer valve with that same spring, what you're going to be doing is, if the install height's supposed to be 1/200 and you put it at 1/300, if this is a 65-pound spring at 1/200, you put it at 1/300, this spring is now going to be operating at like 45 pounds of seat pressure instead of 65. And 45 pounds of seat pressure is not going to hold that valve closed, or not going to prevent it from bouncing anything over about 7,000 RPMs. So these, if you're trying to get big lift on your heads, you know, I'll even show you this head now. This is the head that I'm going to be using to try to break this record. Now it is going in to get flow tested this week. Now I am going to video that, but I just want to show you something. Now I had this head flow tested before, and it flowed pretty good numbers. I didn't have a chance to get it on video. That was back before I did YouTube. But before, when I had this flow tested, this was just a straight shot. I was able to see down the valve and was able to see, oh, if I can get something white under there, you know, I was able to see pretty much clearly down into there. Now what I've done is build a big bump right there. And all in here, I've filled in. Now what that's doing is changing that angle of approach. Now, being able to flow a certain amount of air has a direct correlation to power. There is an actual translation of flow to horsepower. There's an equation. So if your head flows a certain amount, it can make a certain amount of horsepower. It's called volumetric efficiency, and it's limited by the air that the head can flow. There's two different types of flow, CFM and wet flow. The wet flow is getting the air and fuel mixture into that head still in a suspended state, and getting it around that valve, getting it around the short turn curve of that valve. So, sorry again, my camera keeps dying. My phone's full. But yeah, so getting the air to flow around that curve is the most important thing. You do have the wet, you do have the CFM. A lot of the times, if you're just going for maximum CFM, you're gonna really take a hit on your wet flow and how the air is actually coming into the cylinder, and how, you know, the way it flows down into the cylinder and the pattern that it flows in, even the shape of your combustion chamber. All these things really matter, and really turn dividends in power. But you know, you have to go to the umpteenth level past, you know, anything that is really being done out there, or you know, put every single piece of this puzzle together to get that little bit extra horsepower. And basically, so that's it. The flow test is going to come next week. It was supposed to be yesterday, but the guy that does the flow testing of my heads, he basically drops everything. And apparently, he works for Porsche as well. So whenever they call, he basically drops everything. So I had an appointment scheduled for Tuesday. He told me to call him back next week. So I have an appointment for next week. So we'll hopefully get this head flowed. We'll see if it's better or worse with this bump in there. That was basically added with epoxy, and I wanted to make sure there was enough in there. Basically, there's kind of a couple of factors that people play into, that really affect the head flow. One is if you have a basic port design. Say if your basic port design, as basic as it could be, is just a curve like that. The first thing to do to increase that port's flow is to raise the short turn, to make that longer. The second thing you could do is, if you're looking at it from the top, is right before the short turn to make it wider. So raise the floor of the short turn and make that wider. When you raise the short turn and make it wider, it forces it to use the sides of the valve more. And the bigger the hump is right there, the slower the air can slow down and roll around and roll into there. Also the multiple angles. This has to absolutely, like, I can't feel anything. It's just a perfect rollover right here. And that's what 5 angles will do. But yeah, so I mean, there's more videos to come. Sorry it's been taking a long time. I just wanted to make sure everything was correct moving forwards. I had to get my guides put in, have the seats recut, so that was its own day. Then I had to order the custom springs, wait for those to come in. I'm still waiting for my custom seals, or the better seals, to come in. But I have everything else here except for the seals. Once the seals comes in, hopefully I'll have the head flowed by next week. We'll throw the seals in, put the whole head together. I'll do the build video. This thing is really coming out nice so far. We'll do the build video with the Mallory crank and the big cam and everything, and so we'll really get this thing put together. I did order a couple extra of these springs if there's anybody out there that needs them. Also, I have a large assortment of valves. I did post some ads on Craigslist, etc. I'm trying to get rid of some of this stuff that I have. I'm just starting to get a real plethora of stuff starting to pile up around here. So yeah, but more to come. Exciting. And subscribe. Do it.